control system, the safety system you need for this process will also be included in the P&ID. Okay. Then those who need this document is the operations and maintenance and also the construction team. The use is for detailed design, construction, and operation. Okay. So yeah, this is the P&ID for you. It's like the equipment, the drawing that uh, everyone needs as an engineer in the plant. This is usually released to the operations team. While sometimes the operations team might have access to this, but most of the time it's management. So, but they are all important in the industry. Okay, so now um, I'm going to show you. The next slide will be picture of two or one process, the same process, but different diagrams. So I want volunteers or who understood what we just explained in the previous slide to come and tell me the difference between these two diagrams you can see here. If you want to volunteer, please just raise your hand virtually and I will call on you. Okay, Blessing Ben, go ahead.
All right, sir. Thank you, sir. So the difference between this process flow diagram and the pipeline instrumentation diagram is the aspects of the listed, the exact instruments they are using. In the aspects of the valve, which is different from the one shown in the process control, and also the PT. I think that is for the sensors pressure, temperature, something like TIC, LT, all those sensors and anything that they collect information. So in order to tell what is going on in the plant and get data. That's my take, sir. Thank you, sir.
Okay, thank you very much, Blessing. Thank you very much. That was a very good attempt. Okay, Desmond, let's go. Go ahead, Desmond.
Okay, thank you very much. Okay, so the process flow diagram, as you can see, it is just giving us the, though it gave out the equipment, but it's giving us overall process, mass in, mass out. Yes, that's what is giving us the mass balance on that particular equipment there that's within there. And then for the process and instrumentation diagram there, we can see that it has the instrumentation, the piping, and all the other equipments and tags. You can see the pressure transmitter, the level transmitter, and the temperature control sensors. All they are all connected, and they are showing each level. At each level, the exact position shown on the P&ID, whereas on the PFD it is not written. So that's my take.
Okay, thank you very much, Desmond. I appreciate your response. Okay, we have one more question on the chat. Marshall, Marshall, go ahead and say what you have in mind. Marshall, were you raising your hands or?
Okay. Good evening.
Good evening.
Okay, yeah, the first speaker there said it all. What I wanted to point out was the control, just like he listed out the different, one of the difference between the process flow diagram and the P&ID is the control, which looking at it, you can see the level transmitter and the pressure transmitter, which are not seen on the PFD side. So that's basically what's distinguished the two. Thank you.
Okay, thank you, thank you. Thank you very much. That's correct. We have the pressure transmitter here. We have the level transmitter, the temperature indicating control, temperature indication control. And we don't have these information here. We only have, do you know what this is? Anybody? Shahima was raising her hand. Did you drop your hand? Does anyone know what this is? Okay, Shahima,
Yes, I think this.
go ahead, Shahima.
Please, can you come up with your question again, or is still the
Okay,
previous question?
okay, your hands was for the previous question, right?
Yes.
Okay, 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 fine, fine. And do you want to say something about the previous question? Because I have a new question, and the question is this: what this item is. Okay, don't worry, Shahima. Let's go ahead. So this here, we have this on the process line, and it's also here. This is the feed point, the line before this little circle you have here.
I'm sorry, but my network is quite bad, but uh, from what
Okay, no,
I see that this including the flow rate, the pressure and temperature. When you come here, I can't see flow rates, and then yes, I can't see the flow rates. And I can see that this one is sample diagram, but this one is quite complex.
okay,
So
okay. Thank you very much, Shahima. Thank you very much, everybody. You all made good attempt. Okay, so back to what I was trying to say. Okay, we talked about the differences. We have the pressure transmitter, the detail here, and there's a valve up here as well. We don't find this valve here. We don't find any of these valves here, right? Also, this transmitter, we don't find it here. All of this, and also the size of the pipe. We have the size of the pipe. This 2-inch pipe. We don't find the this information here. Meanwhile, this is a heat exchanger. We have 130 degrees here. This means there's an exchange of heat here, right? So this is going in here at this temperature. Okay, this is a very simple diagram, and it's to show you the difference between the PFD and the P&ID. So these documents you will find in the industry. It could be interview question for you, and this will give you what you need to know as the difference between the PFD and the P&ID. Sometimes you might be asked this. Yeah, so it's good to know all of it, but of course you should know this. This is very easy to know. Okay, so yeah. Okay, now going forward, who can tell me what this is? This a BFD, PFD, or P&ID? I expect many hands to be up. I expect many hands to be up this time around. Okay, Desmond is the first hand up. Go ahead, Desmond.
Basically, this is a BFD, block flow diagram.
Okay, can you describe what you see happening? What's happening in this BFD?
Okay, what I can see is we have a feed NG coming in, and then we have NG in, and
Mm-hmm.
then NG out, and also we are still having, it came in as a feeder, but it's having two outlets, so I believe it is just depicting, it's just showing what really happened in the process. Overall process, we have one feed and we have two products. That's all.
Thank you very much. That's excellent. That's an excellent response. So it is a block flow diagram, and we have NG for natural gas. It could be anything you decide to call it. It could be CH4, methane. It depends on what you decide to call it. That's your annotation. So for here, I use natural gas going in, and this is a filter, coalescent filter. Later, I will tell you about this equipment later in the course of this program. You will learn about this filter. I will just give you a brief overview of some equipments you find in the industry. Some you might already have learned about them in the course of your study. Okay, and we have a guy from computer engineering here. Who was that again? Is he here today? Okay, maybe he's not present today. So, uh, so you send natural gas through this filter, right? For you to pass something through a filter, it means this is dirty, right? You need to remove something you don't want from it. So you take out what you want and remove what you don't want, right? In this diagram, it doesn't say this is the one you want or this is the one you don't want. We don't know which one you want and the one you don't want. Okay, for example, which one do you think would be the one you want from here and the one you don't want? Can you tell me? Can anybody tell me? If you have natural gas coming here and then you're passing it through a filter and you have something out. Okay, yes, go ahead, this one.
Okay, I think you want the NG out because natural gas basically what they want is from C4 below is basically the natural gas that we use generally. So what you
Okay,
want is the NG out, and the heaviest C5 might be your byproduct if you're not going to process it further.
okay. Thank you very much. Lesson, go ahead.
Yes, yeah, said most of it. So like the NGL, that is natural gas out, is the one we'll be needing, while the heavies are the byproduct or ones you don't need for your
Oh,
exact product. Thank you.
okay. Thank you very much. You both answered very wonderfully. All right, but now I want to bring something to your attention. Okay, what if, uh, okay, I'll give you an analogy. You know the fruit called cashew, right? You know
Yes,
cashew fruit.
yes,
Okay. Now, it has two parts. It has two parts. Think of this natural gas as these two parts, right? One is the flesh, one is the seed, right? Okay. Now, in biology, you were taught that the one with the flesh is the false fruit, while the seed itself is the main fruit. Am I correct? Do you remember?
Yes, sir.
Okay, good. So now, the utility of the cashew fruit will depend on what you want to get out of the fruit. For example, if my interest is just C5 plus, right? The heavies, C5 and above. I'm going to take C5 and above, and this becomes my main product. And the natural gas becomes the byproduct. Maybe I want to use the natural gas for ammonia production in another plant, right? I don't want the natural gas. Or maybe I want to feed the natural gas to some other company. It means natural gas is my byproduct. It's not my main product. What I need is the heavies because I want to use the heavies for production of naphtha or some other product. So it actually depends. And this is where the concept comes in. You decide what you want to be your byproduct and what you want to be the main product. So depending on what your client requests, if your client says, I want to process C5, this is what I want to process. You cannot force the client to process you cannot decide to design a plant that's going to process natural gas for the client. You have to design a plant. That means this becomes your byproduct, and then the rest of the process will continue from here. So you have to include equipment that will process the heavies and all of that. So you now start to think about what equipment do I need to process the C5 plus, right? You're no longer bothering yourself about this. This is not your headache because this is the headache of another company, right? So you're selling this byproduct to them for them to you make money from it. So you don't care about processing this. You care about processing this because this is where you care about. This is your main product. So it depends on what your concept is, right? Okay, so let's go ahead. Now, this is not very clear because it's an actual diagram, and that is why I blot out the for privacy purposes. I have to close out the company. So uh, this This is just the diagram of exactly what you have here. This is a block flow diagram of what you have here. So I don't know if you could see this properly. I need to zoom it in a bit. Maybe you'll see better if I zoom in. Okay, can you see this? At least the lines, the equipment, can you see it? If you can see, just raise a hand so I can see that you can see it. Anybody? Okay,
It's
thank you
a
very
bit
much.
low.
Okay, it's a bit low. Okay, all right. Let's just pay attention to the lines, okay? Let's just pay attention to the lines. So just follow me as I move, as my cursor moves. So we have the feed gas coming here, which is natural gas. Like I said, this is the block flow diagram is what you have here. Is exactly what you have here. Now, this is the PFD of that block flow diagram. Remember when I said the concept comes. When the concept comes, let's say you wake up from the sleep, you had the dream, you want to build a company. This is what you start with. And then the next stage is to get into the PFD. So you have the natural gas coming here, it goes in. This is the filter. This is the filter we have here. That's it here. And you have the filter and you have the heavies coming down. All of these lines, you didn't see this line in the previous one. All these lines, you didn't see it, but it's here. So these lines come down here and you have your heavies leaving, right? And then from here, this line here, you have the natural gas leaving, the C4, and of course some of the C5 because the efficiency is probably not 100%. So you have some of this going out through here. Okay, but maybe a very small amount that you still take care of before you get into downstream equipments that do not require heavies. Okay, so now this is just your PFD. It is more detailed than your BFD. All right, it contains a few valves. All right, the control line. Okay, and some of the switches. I'm going to tell you about this later in the course. Limit switches that give commands to the valve to open and close. And also, now this stream have divided into several other streams. This going this way, and this other one taking this path to go, and this one going into this device, which is a heat exchanger. This is a heat exchanger. It's similar to the other diagram. Let me go back to this one. It's similar to this diagram. It's a heat exchanger, okay, for exchanging heat. So we have the heat exchanger here, and then it goes through here, exchanges heat, and then it goes back through this point. So this other stream is the stream of the what will cool or heat the product going through. Okay, just follow me. This stream is not the natural gas stream. This is the one that will cool or heat what's going through, what is coming from the feed part, going through the filter, and then through the heat exchanger, and then it leaves this point. All right, and then there's another feed stream that is joining the main stream. Okay, so all of this we didn't see it on the BFD, right? And also you have some other information like the legend, the notes, and then the table of the companies who are involved in the construction or the front end engineering design stage, and also the construction of the company, of the factory or the industry or whichever one it is. This one is for a natural gas company. So it could be for a milk production company, butter production company, soap production company, production company, anything at all that requires conversion of a raw material to a finished product. So this could be its PFD. All right, going to the next one, more complex, more complex. So this one, what do you think this one is? I need to zoom out. Yes, go ahead, this one.
P&ID.
Yes, exactly.
Process.
This is Yes, process. What? Go ahead.
No, I said it's a P&ID.
Okay. And what's the meaning of P&ID?
Process and instrumentation diagram.
Okay, not quite. It's piping and instrumentation diagram. Why PFD is process flow diagram. Okay, someone asked a question. Listen,
Okay.
Ben. Please, sir, what is the major difference between a front-end engineering developer and a process engineer dealing with PFD and P&ID? Okay, front-end engineering developer. There is there are where the roles are interlapping, right? There are where the roles are overlapping for the front-end engineering developer. The front-end engineering developer he is skilled in doing the calculations, uh, development of they are basically the same. They're basically the same, but he has to deal with the calculations, detailed calculations, deep and complex calculations. While the process, uh, you said process design, process engineer dealing with PFD. That's basically a process design engineer. A process design engineer has to do with the design. In fact, they are just different names for one thing. But depending on the scope of the project, their roles might be slightly different depending on the scope of the project. It depends on the scope of the project. For example, front-end engineering design developer can also be a process engineer dealing with PFD and P&ID because they have the same skills. They have the same skills. But depending on the scope of the project, they could have slightly different roles. Right. Okay. So just know they are basically the same because coming to the chart I showed you before, your you have your design scope here. This is your design scope, and both are responsible for the design scope, right? So that's it. Thank you. You're welcome, Blessing Ben. Okay, it's 10:04 already. It's 10:04 already. So okay, I want us to do this. So which one would be PID and PFD, the left or the right? So let's do it this way. If you say P and ID would be the one on the left, use thumbs up. Use a thumbs up reaction. If you say the one with I want everyone to give a response to this one. I want everyone to participate. That is why I want us to do it this way. I don't want a single answer. So if you say P&ID is the one on the top left, use a thumbs up. If you say P&ID is the one on the bottom right, use use a hand like this, like raising hand. So we have two things, thumbs up and raising hands. So I think we should all drop it in the chat. Let's drop it in the chat so I can see everybody's response because I can see everybody's face on the screen here. Let's use the chat.
Please, I'll come again with the question.
Okay,
Please,
if you say
come again with the
PN,
question.
yeah, PNID with a thumbs up for the top right. Okay, PNID. If you say it's PNID, use a thumbs up for the top right, the one on the top right. That's this one. Okay, but if you say PNID is the bottom right, just use any other reaction apart from thumbs up. I think that's better. Top left. I'm sorry, I was saying top right. This is top left. So top left, thumbs up. Then bottom right, any other reaction. If you say is PNID. Okay. Have has everyone answered? Okay, I'm seeing your responses. I need everyone to answer. And if everyone has answered, I want the moderator of the meeting to notify me on the chat that everyone has answered. Then I go through it. Okay, let me start. So uh, Marshall says bottom right is P&ID. Okay, Blessing Ben says the same P&ID for bottom right. So, and Promise says uh, P&ID bottom right. Okay, and we have Jewe says uh, PFD at the left. Okay, okay, fine. So if you say PFD at the left, it means P&ID at the right. All right. Then we have Caleb, the same. Okay. P. Okay, Jones said P&ID is at the bottom left, while the other is at the top right. Okay, it's not very clear what you said, Jones. PID at the bottom left. Bottom left, you mean top left? Because I only have at the top left and the bottom right. Okay,
Sorry,
Jones,
bottom right.
okay,
Sorry,
bottom
bottom
right
right.
is okay, bottom right. Okay, so everyone got it correctly. Everyone got it correctly. So we're all correct. So this is your PFD and this is your P&ID. And why did you say that? Why did you say this is a P&ID and why this is PFD? Why did you say that? Yes, Desmond, go ahead.
Okay, why I said the one at the bottom left, bottom right is the P&ID is because if you can see very well,
Mm-hmm.
this particular one is having every unit, the piping, and
Mm-hmm.
all the materials and equipment that are
Mm-hmm.
involved in the process. They are being tagged, they are being named, and they have their, I believe they have their codes
Mm-hmm.
attached to them, their names attached to them. Why that at the top left is just showing the equipment, showing the line sizing. No, just the lines. And then the lines are numbered. There are no tags of every other loop that is happening in the the process. So that's why I said particularly the one at the bottom left. Bottom right is the P&ID.
Okay, thank you very much. Thank you very much. Okay, Jewe, can you say what you want to say? Go ahead.
Okay, thank you very much, sir. So why I said the one at the top left is the PFD. Why
Mm-hmm.
during your presentation, I noticed that the PFD looked more simpler compared to the P&ID draft or drawing you showed us. So
Mm-hmm.
from what I saw earlier, is as though the P&ID is very much complex, having both the instruments, the valves, as
Mm-hmm.
well as the entire layout, design, and equipment. But it's as though the PFD is showing a particular section, like it got in, like a simpler section got to from the P&ID to explain each stage. Thank you, sir.
Mm-hmm. Okay, thank you very much. Thank you very much. That is very correct. This is very correct. Okay, so we have almost come to the end of this session, but that's not all. Don't be in a hurry to go because I have a small gift for you. And just give me a moment and I'll pull it up on the screen. So the gift I have for you, this. So just in a minute, I will send it to the screen. Okay. You like quizzes, right? Do you?
Yes, sir.
Okay, so let's do a little quiz. All right. So I don't know if you're connected with your phone or with your. I'm gonna drop this on the chat for those who want to use the code. I don't know if you can see the screen. Can you?
Yes, sir, we can see.
Okay. So I'm gonna drop the link on the chat, and okay, there's the link, and this is the code. You can also scan your the QR code, and you will join. You see the questions, and this is the code for it. And I'm gonna zoom this so that you can see the QR code. You scan it. Currently, I have 0. Okay, Anthony has joined. Okay, I'm gonna zoom back. 6 people have joined. Eight. So how many do we have in the start? 12 people are present, right? Okay, 14. We have 14 people present, so I expect 14. 14. Okay, we have 12 joined already. So I can see your beautiful faces with your clothes. You can change the pictures, the faces, by the way, so to whatever you want. Maybe you like Pokemon or you like animes like Naruto and the rest of them. You can choose what looks like what you like. Or you like Aki and Popo, you can change it to Aki and Popo if you find it. So that's by the way. All right. So, uh, are you ready? I'm about to click start. And for some questions, you have only 30 seconds to answer it. Some are multi-choice. Some are, you have to order it according to the most correct one, the one that's correct. And that question will be 1 minute. So, but the rest are 30 seconds. So, get ready to start. Sound is. Do you see the questions? Okay. And please don't worry, we're just having fun. Even if you don't get it correctly, we will learn it and you know it. So do not worry, don't be shy, don't be ashamed. Feel free. We're all here to learn, so don't worry, make an attempt. Okay, and everyone has attempted at least 50%. Has everyone finished? Those who are finished, drop a reaction in the chat. I can see only two finished. And, okay, okay, Marshall is done. Desmond is done. Jerry is done. Okay, Onyinye is done. Moses is done. Enak is done. Shay is done. Okay. Yes, is done. Caleb is done. So, I think more than 50% have completed. Okay, so let's see. So, are we all here? Do I have your attention?
Yes.
Yes.
Oh,
Yes.
okay. Was it simple?
Very simple, sir.
Oh, great. I like that. Okay. So, the first question, what is the main role of a process engineer? I have 9 correct and 2 incorrect answers. Okay. So, process design engineer, actually. So, it says troubleshooting equipment failures, designing safety systems, creating preliminary PFDs, P&IDs, and basic design specs, and that's the answer you need. Okay. Then, which type of engineer is responsible for troubleshooting and solving and problem solving in operations? So, of course, it's your process operations engineer, and everyone got this correct, which is good. Process flow diagram. And which role? Oh, okay, I haven't even taught this, so this question is not supposed to be here. But, well, okay, I mentioned this. I mentioned this for the process simulations engineer because it is an open source software, Aspen Plus. So I mentioned this. Okay, we have 13 correct answers here, and we have main goal of the process solution engineer, which is what to optimize processes for efficiency. P&ID, P&ID. This was one of the questions during the session, during the session, and we said it's piping and instrumentation diagram. Piping and instrumentation diagram. The essence of this quiz is so that we strengthen the what we have learned so far, so that it remains in your head. If you fail it, you get to know it now. So, which engineering role focuses on yield, energy use, and downtime? And what do we say is the answer to incorrect? So, majority has the answer, which is process operations engineer, because they have to pay attention to the product yield. They are the operations. They have what's going on, the production, the yield, the energy consumption, downtime, and all of that. Okay, and then we have what does BFD mean? Block flow diagram, block flow diagram. Okay, which of the following diagrams provide the highest level of detail, including valves, sensors, and the rest of them, which is your P&ID. Everyone got it correctly. And then put the diagrams in order from the simplest to the most detailed. You all got this correct. I'm very proud of all of you. Okay, you all got this correct. So, which is the BFD, PFD, and P&ID according to the way I presented to you. So that is it. Thank you very much. And so I end the game. So this is where we will end the lesson. Of course, you have your winners. I don't know who this is. 903663. A code, but we have second place for Jerry and Anthony, third place. So the accuracy of the class, 91%. So congratulations to everybody. You can clap for yourselves. Give yourself a virtual clap. Can I have your reactions? Clap for yourself. Okay. So, I'm gonna end this now. Okay, so this will be the end of the lesson. Thank you very much for having me. I remain Alan Emma Kolam, your mentor for this program. and we will meet next week. I will communicate the time we will meet. If there are changes, I will communicate to the lecture hub team and they will communicate to you. Okay, so for now, enjoy the rest of your week and I wish you success and all you desire for yourself. So, bye bye.
Thank you very much. Have a nice week ahead.
All right, sir. Thank you very, very much, sir. Really appreciate your time with us. And I'm looking forward to the next class. So yeah, thank you,
Okay,
sir.
thank you. And if you have
Good
any
luck, sir.
questions, you can communicate the questions to the lecture hub teams and then you can send to me, okay? Right. So good night and have a wonderful night rest. Bye.
All right, thank you, sir. Thank you, everyone. Thank you, everyone, for joining, and have a great night. Yeah.
Moderator, are you not here?
Yeah, we are with you. Like,
Okay, meeting is done.
yeah, we're done. Yeah. See you next class. Thank you very much.
Okay.
So any information, we'll pass it across through the group.
Okay, thank you. Have a nice night ahead.
Yeah.